Alright, so today we're going to look at how to solve rational equations. This is going to be a very similar process that we've been doing with operations. The only difference now is that we're actually looking at equations as opposed to just a simple expression that we're trying to simplify. So there's two different methods that you can use to solve a rational equation. One of them you've been using for a long time, especially with proportions, and that is cross-multiplying. Cross-multiplying is going to be the easiest method if you have just a combined fraction on the left and one combined fraction on the right. So what we're going to do, I'm going to cross-multiply on the left side of the equal sign, and then I'm going to cross-multiply on the right side of the equal sign. And then from here, it's just a normal algebraic expression, equation. So I'm just going to distribute. And then move all your x's to the same side, move all your numbers to the other side, and you get your answer. Now, it's going to be really important going forward. We always want to check our answers just because it's good practice, but it's going to be really important in this unit and especially in our next one, because sometimes you're going to work this all out correctly and you're going to get something that's called an extraneous solution, which basically means that even though it worked out algebraically, it doesn't make sense for the original problem. An example of that would be like if I am taking the square root of a negative number, or if I am dividing by 0. Okay, those are things we can't actually do. So to make sure this answer works, I'm actually going to go back and I'm going to check to make sure that this answer actually gives us the correct answer. So I'm going to plug in -2 everywhere there was an x in my original problem. So that gives me 3 over -1. This gives me 9 over -3. And both of those things are -3. So that answer does work. It's also very nice because when it comes to time for a test, you'll know for sure that you got your answer right. All right, the second method, this works best if you have multiple fractions that are being added or subtracted, and especially if they're close to having the same denominator. So what we're going to do is we're going to get that common denominator. Okay, so I'm going to get all of these with the same denominator, which means I'm going to need to multiply this one by 4, this one by x, and this one by 4. So that gives me 20 over 4x plus 7x over 4x and -36 over 4x. Now, when it comes to solving equations, if your denominators are the same, we really don't need to worry about them when it comes to solving our equation. Because if those are all the same thing, okay, if I have 1/2 plus x over 2 equals 5 over 2, okay, I would just subtract that 1/2. The denominators stay the same when I add and subtract. So it doesn't matter then what that denominator is because that denominator is going to stay the same. So all I need to worry about are the numerators, and that's the equation that I'm going to solve. So I'm just going to rewrite this with just the numerators because, again, we already know that our denominators match. And then, again, it's just a basic algebraic equation, so I get -8. And then I'm going to go and check my answer. All right, so let's work with the left side. So I need a common denominator, so this one gets multiplied by 2. And just remember with that fraction, that negative right now is on that 8, but that just means the fraction as a whole is a negative. Okay, so if you have -5 over 8, that's the same thing as 5 over -8, which is the same thing as a -5 over 8. So it doesn't matter where the negative is. If there is one negative on that fraction, the whole fraction is a negative. Okay, so this is a -5 over 8 plus 14 over 8. And on the right side, I have two negatives. A negative divided by negative becomes positive. So both of these are 9 over 8, which means my solution works. Now, either of those methods can work. It's up to you to pick which one you think is going to be best for the problem that you have. If you want to use some sort of combination of them, you can. For example, if I wanted to rework this question, one of the things I could have done, I could move this 5x to the other side because they already have the same denominator. And that would be -14 over x. And then I could cross multiply from here, and I would still end up getting the same answer. Okay, so that's just another method that you could use. It just kind of combines the two together. All right, so let's look at a little bit of a harder example. So what I need to do here, I need to get a common denominator, because this one's going to be pretty messy to try to combine and cross multiply. So if I factor first, this becomes x plus 3x minus 3. So the right fraction needs x minus 3. This left fraction is going to need x plus 3. By doing that, I have the common denominators. So at this point, I can ignore the denominators and just work with those numerators. All right, and then let's go ahead and distribute and combine like terms. And you'll notice this one's going to be a little bit more complicated of an equation because it's quadratic. Okay, just remember when you're solving quadratics, they have to be equal to 0 in order to factor or use quadratic formula or anything else. So I'm going to set this equal to 0. And I'm going to subtract correctly. And then at this point we can factor. Now, normally if it's just an expression, that 2 that both of those have would need to get factored out. But because it's an equation, this is when it's okay to actually divide by that number. Because I could actually divide both sides, and that won't change my equation. Whereas if it was just an expression, you're actually changing the expression. That's why we had to factor it out. Now, you could factor it out, but since we're trying to solve, it really won't affect our answer, which is why we're just going to go ahead and take out that 2. Okay, so now we need to factor. Now remember, when a is greater than 1, it's a little bit of a harder factoring process. So I need 2 numbers that multiply to negative 18 that add to 3. And I'm going to rewrite my middle with those 2 numbers. Then I'm going to cut it in half, take out 2x, take out minus 3. So my factors are 2x minus 3 and x plus 3. Now on this one though, we need to find our answers, okay? We're not just solving for factors, we're trying to actually find our solutions. So the solutions from those factors would be and x equals negative 3. But again, we always said we need to make sure that we check our answers, and this is a case where we absolutely have to. Because look at negative 3. If I take negative 3 and I plug it in for x right here, I'm going to have a negative 12 divided by 0, which we know we cannot do. So because that negative 3 is going to have me divide by 0, that negative 3 is an extraneous solution. So we are not going to use that as one of our answers. The only answer here that works is 3 over 2. All right, so if you feel pretty comfortable with this, go ahead and pause the video and then try and work out this next example. And I'm about to go over this one, but pause it and try and work this one out on your own. Okay, so the first thing I would do here is I would factor. So this fraction over here on the left is going to need an x plus 1. This factor here in the middle is going to need both of them, which is x squared minus 1. And just remember, if it's a whole number, it is a whole number over 1. So that's why it needs the entire denominator. Okay, and now my denominators all match. Okay, my denominators are all x squared minus 1. So I'm going to just look at the numerators. So this is 7 times x plus 1 minus 5 times x squared minus 1 equals 6. Okay, and then distribute. So I have 7x plus 7 minus 5x squared plus 5. All right, and then from here, I can go ahead and combine like terms. This one is also quadratic. Typically with quadratic equations, I think it's easier if your a value is positive. So I'm going to move everything to the right so that I have a positive 5x squared. and then I'm going to have minus 6x minus 6. Again, to factor, I would need numbers that multiplied to negative 30 and added to a negative 7, and then I would split up the middle into those two things. 5x comes out. So these are my factors. So I get negative 3/5 and x equals 2. Again, plug both of these in and make sure they actually work. So at first glance, they don't make you divide by 0, which is a good sign. But you also want to double check just to make sure you didn't make any sort of mistake somewhere on there. All right, so the last thing that we're going to look at are some word problems. Okay, now we started these actually earlier, but today we're going to look at a couple more complicated ones. But I'm going to go ahead and review how to do these first word problems. So these are just some basic rate questions. So this tells us that Joe can paint a house in 3 hours and Sam can paint a house in 5 hours. We want to know how long it will take if they paint it together. So we can use any of these formulas and we can just need to follow these steps. So the first step is to find their individual rates. So Joe's rate is that he can paint one house in 3 hours. Sam's rate is that he can paint one house in 5 hours. So if we want to find their combined rate, we are going to add those together. Well, in order to add them, we need a common denominator. So that gives me 8 over 15. That is their combined rate. So that is not how long it will take them. We use that rate to answer our question. So when it comes to word problems, it's very important that you always answer the question that was asked. So in this case, it's not saying, hey, what would be their combined rate? Okay, this is, we said it was one house in 3 hours. So this is their rate. They can do 8 houses in 15 hours. So if they can do 8 houses in 15 hours, they could do one house in 15 divided by 8 hours. So 15 over 8 is my time. Right? If I wanted to convert that, that would be the same thing as 1 7/8 of an hour. And if you want to turn 7/8 into minutes, that would be the most specific answer. All right, so let's look at another example here. We've got Jim, Pam, and Dwight that are painting a room together. It takes all 3 of them 2 hours. So their combined rate we already know. Okay, Jim is he can do the job in 1 hour, one job in 5 hours. Pam can do one room in 6 hours. Dwight, we don't know. So we're just going to call it X. So again, just to get that solved for that X, we are going to combine these two together. Let's get our common denominator. So this is 11 over 30. I would subtract, and again, I'm going to get a common denominator. So Dwight's rate would be 4 over 30. So that means he can do 4 rooms in 30 hours. Okay, but what we care about is that how long it takes him to do just the one room. So again, divide those by 4, and one room would take him 30 over 4 hours, which is 7.5. Okay, so those are kind of some basic examples to kind of see this process. What we're going to look at now is actually some of these with a rational function. So it's actually going to be more of an equation. So this first one, the wording is a bit complicated, but I want you to pay attention to the process. So sterling silver is an alloy that has 92.5% silver and 7.5% copper by weight. You have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. So we're trying to figure out how much silver we need to add to make sterling silver. Okay, so what we need to look at here, we already have a certain amount of copper. Okay, we want our final solution to have 7.5% copper. Okay, so that's what we want to have in our final total. So that percentage would be 7.5 over 100. Okay, that's the percent copper we want to have. Now, we need to figure out how much silver to add. So what we're going to look at, the percent is going to be equivalent to the total weight. So what we're going to look at is the weight of the copper over the total weight. Okay, and that should be 7.5%, okay, in order for it to be sterling silver. So let's look at what we actually have. So the actual weight we have right now, we have 20% copper of 15 ounces, that's 20% copper. So the way we would write 15 ounces of something that's 20%, that weight would be 0.2 times 15. That's how much copper we currently have. The total weight is going to be the copper plus however much sterling silver we add, or however much silver that we add. Well, we don't know how much silver we're adding. That's what we're trying to figure out. So that's where my x goes. Okay, the hardest part of this one is setting it up. But again, this is the percent of copper over here on the left. And then over here on the right, this is the weight of the copper. And then this is our total weight. So then from here, again, we can just cross multiply and solve for x. And when I cross multiply, I end up getting that this is 300. And then this is going to be 112.5 plus 7.5 if I distribute. So subtract and divide, and I get that x is equal to 25. So I would need to add 25 ounces of pure silver, okay, in order the percentage that I'm looking for. Okay, the hard thing about this one is there's a lot of extra numbers kind of floating around that we actually didn't need to solve our problem. All right, the last one we're going to look at, very similar to the first two examples, but again, we're going to look at this actually as a rational function. So it says it takes Harry 7 more hours to paint the kitchen than it takes Sally to do the same job. Okay, together they can complete it in 12 hours. So again, what we need to look at is their rates. Okay, so Harry takes, well, let's look at Sally. We don't know how long Sally takes, so we're going to say her rate is 1 over x. Harry's rate is 7 more hours, so his is x plus 7. Their combined rate is 12. So then, again, we just have a basic algebraic expression here. So let's go ahead and get a common denominator. And this looks a lot like the rational functions we've been working with. Okay, so I end up with x plus 7 over that common denominator. And then you can either get that same denominator over here on the right and just set the tops equal, or you can cross multiply. Either way you'll get there. So at this point, I'm going to go ahead and cross multiply. So I get that x squared plus 7x is going to be 24x plus 84. This is quadratic, so we got to set it equal to 0. Then we can factor. And we get two possible solutions. One of those solutions is 21, one of those solutions is -4. Okay, even though -4 works out algebraically, it does not make sense for the problem because it's not going to take you a negative amount of time to do a job. Now, 21 works for our x value, but again, we always need to make sure you answer the question that was asked. So what was asked was how long does it take Harry to complete that job? Okay, to figure out how long it takes him, remember, he takes 7 more hours than Sally does, and Sally was our x. So that means it's going to take Harry 21 plus 7, which is 28 hours. All right, and that is it for rational equations. So again, just remember when it comes to solving, you can use either method that's easier for you. You can either cross multiply or you can get a common denominator. If you get a common denominator for every single fraction, then at that point you can ignore the denominators and just work with the numerators, because if the denominators match, then we only care that the numerators match.